Given question, 4-stroke gasoline engine of 1.7 liter capacity is to develop maximum power at 5000 revolutions per minute. The volumetric efficiency is 75% and the air-fuel ratio is 15:1. Two carburetors are fitted. It is expected that at maximum power the air speed at the choke is 100 meters per second. Coefficient of discharge for venturi is 0.80 and the coefficient of discharge for the main jet is 0.65. Allowance should be made for emulsion tube, the diameter of which can be taken as 1/3 of choke diameter. The gasoline surface is 6 mm below the choke at this engine condition. Calculate the sizes of the suitable choke and main jet. The specific gravity of gasoline is 0.72. Initial pressure 1 bar and initial temperature 300 Kelvin. Let us understand given data with the help of diagram of simple jet carburetor. We will consider the suffix 1 at the inlet of the air. We will consider the suffix 2 at the venturi throat or choke. We will consider the suffix F at the nozzle of fuel metering orifice. If we observe the given data, gasoline engine capacity is given 1.7 liter. So this engine capacity is known as volume of the cylinder. So we will give here the notation V cylinder. And it is always measured in meter cube. So standard unit is meter cube. So how to convert? So which is equal to 1.7 into 10 raised to minus 3 meter cube. Number of revolutions 5000 rpm. So number of revolutions notation is n, that is small n, and the standard unit is rps. So how to take this, which is equal to 5000 divided by 60 rps. So to calculate the rate of flow, we have to convert this rpm, revolution per minute, into revolution per second. Volumetric efficiency 75%, that is neta V. So it is 75%, so which is equal to 75 by 100 and which is equal to 0.75. Emulsion tube diameter is equal to 1/3 choke diameter. Now if we observe the diagram at the venturi throat, then there is the tube which contains the fuel, or this fuel is known as gasoline, and gasoline means petrol. Now for this emulsion tube diameter, so for this tube we will consider the notation small d is equal to 1/3 choke diameter. So this choke is known as the diameter at the venturi throat, so which is equal to 1/3 d2. Gasoline surface 6 mm below the choke. Now again if we observe the level of the fuel, it is the 6 mm below the choke. So here is the venturi throat and the level of the fuel gasoline, the difference is equal to 6 mm. So difference is known with letter H. So this H is equal to 6 mm. Standard unit is meter. So 6 into 10 raised to minus 4 meters. So this is the value of H. Then the number of carburetors. So in this engine, gasoline engine, there are two numbers of carburetors. So number of carburetors is equal to 2. Air fuel ratio. So this ratio is known as A to F ratio and it is 15:1. So whenever this air, quantity of air is 15, then the fuel, quantity of fuel is equal to 1. So this ratio is air to fuel is 15:1. Air speed at the choke. So we know that we will use the suffix 2 at the choke. So the air speed which is entering at the choke is 100 meter per second. So C2. So we will use the suffix 2. So this is the value of C2 is 100 meter per second. Now coefficient of discharge. So this coefficient of discharge at the venturi and at the main jet is given. So at the venturi, this is the coefficient of discharge is known as the for air, and a main jet, that means it is for the fuel. So remember, through the venturi air is passing from the air inlet, and through the main jet fuel is passing through the nozzle of the fuel metering orifice. So for venturi, this coefficient of discharge CDA, and main jet it is CDF. So these values are given 0.80 and 0.65. Specific gravity of gasoline, so it is 0.72. So from the specific gravity we can calculate the density of gasoline. So gasoline is fuel. So what is the density of fuel? Rho F. So rho F is equal to 0.72 into 10 raised to 3, that is 720. So this is the density of fuel we can calculate from the specific gravity. At air inlet, pressure is given, temperature is given. So we know that at the inlet of the carburetor we will consider the suffix 1. So this pressure P1 is equal to 1 bar and temperature T1 is equal to 300 Kelvin. Now we have to calculate size of the choke. So this size is in the form of circle. So it is the circular shape. So size of the choke, that means we have to calculate the diameter of the choke. So for choke we will use the suffix 2, that is D2 we have to calculate. And size of the jet. So this is jet, that means the fuel jet or gasoline jet. So this is also in circular shape. So we have to calculate the diameter of the jet, and that is known as DF. So we will show here, we have to calculate the value of DF. So to calculate D2 and DF, we will find out the answer. Now first we will find out the mass flow rate of air. So we don't know what is the mass flow rate of air. So for that we require to calculate the density of air as well as volume flow rate at the inlet. Then we can calculate the mass flow rate of air. So first we will calculate the actual volume flow rate of air sucked. So there is the gasoline engine with capacity given, volumetric efficiency is also given, revolutions per minute or RPM is also given. So there are number of carburetors too. So we will calculate the total actual volume flow rate of air sucked in the carburetor. So it is neta V, that is the volumetric efficiency multiplied by the engine capacity V cylinder multiplied by the RPM by 2 into 1 by 60. So 1 by 60, because RPM we have to convert it into RPS. So if the revolution in RPS is given, then 1 by 60 is not necessary to use. So remember, this formula is volumetric efficiency multiplied by the engine capacity multiplied by the RPM by 2 or RPS by 2. Now we will put the values. So when we put the values, then we will get the answer 0.053125 meter cube per second. So this is the total actual volume, but number of carburetors is equal to 2. So in each carburetor, what is the volume flow rate? So we will consider for the calculation one carburetor only. So we have to divide it by 2. So volume flow rate through each carburetor. So this is the value V1. This volume flow rate is known as V1. So which is equal to 0.0265 meter cube per second. So this is the volume flow rate. Now from this flow rate we can calculate the density. So we know that 1 divided by density is known as volume. And in terms of density we have formula P1 V1 is equal to RT1. So M, that is the unit mass flow rate. So we will consider for this unit M is equal to 1. So P1 V1 is equal to M RT1, but M is equal to 1. So P1 V1 is equal to RT1. Now instead of V1 we will use the density 1 by rho A, because this is the volume flow rate of air. So 1 by rho A. So P1 is known 1 bar. So for the calculation we will use in Newton per meter square. So 1 into 10 raised to 5 Newton per meter square. V1 1 by rho A R, that is the gas constant 287 joule per kilogram Kelvin, and T1 300 Kelvin. So rho A is equal to 1.16 kilogram per meter cube. So what is the mass flow rate? So mass flow rate in kilogram per second. So if we multiply these two terms, that is V1 and rho A, then now we will observe this unit. So here is meter cube per second multiplied by kilogram per meter cube. So this meter cube is getting cancelled, and we will get the mass flow rate in kilogram per second. So mass flow rate of air is equal to 0.030 kilogram per second. Now we will apply the formula for the velocity of air at the throat. So at throat we will use the suffix 2. So this velocity is C2, and the value of C2 is mentioned in the question. So formula is under root of 2 CPT1 in the square bracket 1 minus P2 by P1 raised to gamma minus 1 by gamma. Now what is this Cp? So specific heat at constant pressure, and its value is 1005 joule per kilogram Kelvin. T1 is the initial temperature of air, that is this T1 300 Kelvin. Then P2 by P1 is the ratio at 0.2 and 1, and the value of gamma is 1.4. So this is the ratio of specific heats, that is specific heat at constant pressure and specific heat at constant volume. So its value is 1.4. Now we will put the values. So when we put value, then here is the square root. So we will remove the square root by squaring on both the sides. So here is 100 square, and when we square the right hand side, then this square root is getting cancelled. So when we calculate this, we will get 603,000 inside the bracket 1 minus P2 by P1 raised to 0.28. So gamma minus 1 is 0.4 and gamma is 1.4. Now we have to find out the ratio of P2 by P1. So we will transfer this term to the right hand side, this bracket which is having negative sign, and this answer to the left hand side. So we will get P2 by P1 raised to 0.28 is equal to 0.98. So we will take here, we will take raised to 1 by 0.28 on both the sides. So here if I divide 0.28 raised to 0.28 on both the sides, so this side also raised to 1 by 0.28. So this is getting cancelled. So here only P2 by P1 which is equal to 0.98 raised to 1 by 0.28 which is equal to 0.93. So pressure at point 1 P1 is given. So P2 is equal to 0.93 bar. So why the unit bar? Because this P1 is equal to 1 bar. So same unit, if we multiply here with 1 bar, then P2 is 0.93 bar. Now we will calculate volume flow rate at the choke. So at choke we will use the suffix 2, that is V2. So value of V1 is known, as well as the pressure P2 and P1 is also known. So we will use the relation in between volume and pressure. So this relation is V2 by V1 is equal to P1 by P2 raised to 1 by gamma. So gamma is 1.4. So P1 is 1 bar, P2 is 0.93 bar. So V1 we will transfer to the right hand side. So we will get V2 is equal to 0.0279 meter cube per second. Now for this V2 we have formula in terms of cross sectional area A2. So this formula is V2 is equal to A2, that is the cross sectional area at point 2, C2 that is the velocity at point 2, and the coefficient of discharge of air. So this coefficient of discharge of the air or at the venturi, that is at point 2, CDA is given 0.80. So we have to use this. So we will use this value 0.80. C2 is also mentioned in the question, and this V2 we have calculated. So A2 is equal to 3.48 into 10 raised to minus 4. Now if we observe the diagram, then this cross sectional area at point 2, it contains the venturi or this total choke as well as the emulsion tube which is having the diameter D. So if we observe, the emulsion tube diameter is equal to 1 by 3 of the choke diameter. So this choke diameter is D2 and emulsion tube diameter is D. So this cross sectional area A2 is equal to, how we can define, it is pi by 4 D2 minus D bracket square. So this D2, that means total choke diameter, we have to take this diameter of the emulsion tube, we have to subtract this. So then this D2 minus D bracket square. So with the help of diagram we can understand this. So we will put the value of A2, pi by 4 D2 minus D bracket square, and on the right hand side we will take the value as it is. Now we will simplify this. So value of D is equal to 1 by 3 D2. So we will put here 1 by 3 D2 bracket square. So here is D2 square minus D2 by 3 bracket square. Now we will transfer this pi by 4 to the right hand side. Then it will become 4.43 into 10 raised to minus 4. Now D2 square we will take the common term. So here 1 minus 1 by 3 square is known as 1 by 9. So D2 square inside the bracket 1 minus 1 by 9. So when we solve this bracket and transfer to the right hand side, then we will get D2 square is equal to 5.03 into 10 raised to minus 4. So D2 is equal to, square root of this term is 2.24 into 10 raised to minus 4 meter. So this is the answer of first question, size of the choke, that is the diameter D2 is 2.24 into 10 raised to minus 4 meter. Air to fuel ratio is given 15:1. Mass flow rate of air is calculated. So from this air fuel ratio we can calculate mass flow rate of fuel. So ratio of mass flow rate of air to the mass flow rate of the fuel is also equal to 15:1. So m dot f is equal to 2 into 10 raised to minus 3 kilogram per second. So same unit we have to give as we have used for the mass flow rate of the air. Now from this mass flow rate of fuel we have formula. So this is the formula, mass flow rate of fuel is equal to coefficient of discharge of fuel multiplied by cross sectional area of the fuel metering orifice, that is AF, under root of 2 multiplied by density of fuel multiplied by the pressure difference between the fuel metering orifice, that is delta PF. So how to calculate this delta PF? It is not mentioned in the question. So for this delta PF we have formula. So this is the formula, P1 minus P2. So P1 is mentioned in the question, P2 we have calculated minus GH rho F. So what is this G? That is the axial gravity. G, value of G is 9.81. So this is the value of G. Value of H, so this is the difference in between level, gasoline surface 6 mm below the choke, that is the surface of the fuel or gasoline and this choke. So this H is given in millimeter, we have to convert it into meter, and rho F, that is the density of fuel. So it is given in the data and we have calculated the density of the fuel. Now when we put the value, then we will get the answer. So we have to put the value. M dot F is 0.002. Then CDF. So this coefficient of discharge of the main jet is given. That means it is CDF 0.65. AF we have to calculate under root of 2 into rho F. So 2 into 720 inside the bracket. Now for this delta PF we have to make the separate calculation. Now this P1 and P2 we have used in bar, that is P1 is 1 bar, P2 is 0.93 bar, but the standard unit is Newton per meter square. So we will take this P1 minus P2 bracket complete into 10 raised to minus 5. Sorry, 10 raised to 5. 10 raised to 5 multiplied by 10 raised to 5. So this is the first term. Then minus GH rho F. So G is 9.81 meter per second square. Then H is 6 into 10 raised to minus 4, rho F is 720. So this is the second term. So we have to first calculate this first term minus we have to take this second term, and then we have to multiply with 2 into 720. So under root of this term is given 100,73897.4. And on the left hand side we will transfer this 0.65 to the left hand side. So 0.00307. So AF is equal to, so we will get, so when we calculate this we will get 9.67 into 10 raised to minus 7. Now what is this AF? Pi by 4 df square. So this is pi by 4 df square. So df is equal to, we will transfer this term and we will take the under root, then we will get df 1.10 into 10 raised to minus 3 meters. So this is the answer of second question. Size of jet, that is df is equal to